Hi, in this video I'm going to review how to choose x and y if we want to plot a graph with a certain variable on the x and a certain variable on the y. So let's assume that we have a formula that we want to verify, or an experiment, let's say, where we are collecting some data where we want to measure some kind of quantity. And we want to have this data in this way. So we want to be able to linearize the data in such a way that after, in Logger Pro, we can have a best fit analysis. And then maybe we can, I don't know, find, for instance, that the slope here of this line is some quantity that we need. Okay. For instance, the speed of sound or the specific heat capacity or something else. So in order to do this, we need to understand what to put in the x and what to put in the y. Now, in order to do this, we need to have the formula, the expression that the data are following. So somehow the theoretical equations, the theoretical equation that we need. For instance, it could be v equal lambda times f. Now, if we want a v as our slope, we have to go and look how Logger Pro actually describe this line. Logger Pro normally describe this line as y equal a times x. So we need to transform our expression into something like that, and then read off this expression the x and the y. So in this case, if v is the slope, clearly we have to somehow put aside the v something else. So in this case, we can, for instance, either say lambda it's equal to v divided by f, and this can be, of course, written as v times 1 over f, or we could just have the frequency as something that is the speed divided by the wavelength, which can be also written as v times 1 over lambda. Now let's study case 1, and let's say that this is case 2. Now in case 1, you recognize now that the expression becomes lambda equal v times 1 over f. So if now we compare mechanically to this expression over here, we see that v is going to be our slope, 1 over f it's our x, and lambda it's our y. So in order to have the speed as the slope of a line that is the best fit line, this is the slope v, we have to put in the x 1 over f, and we have to put in the y lambda. The other case, the second case, it's very similar. So we have f equal v times 1 over lambda. Let's compare it again with the line a times x. We need to do again the same thing. So if we want v to be our a, then we need to put 1 over lambda as our x and f as our y. So we need to create a graph where on the x I will put 1 over lambda, and on the y I'm going to put the frequencies. And the data are probably going to describe a line where the slope should be v. This is something that we need to do also if the expression is more complicated. For example, let's take a third case, and let's say that instead of the wave equation, I'm studying, for example, thermal energy, and I have the delta E thermal, it's equal to m times c times delta T, so the change in temperature, and I want to find C. Well, in this case, I need, first of all, to write down y equal a times x. And since C is the thing that I want to find, it's going to become my slope. And if this is my slope, it means that m times delta T, it's going to be x, and delta E thermal, it's going to be my y. So it means that if I realize a graph where in the x I put m times delta T and in the y I put delta E thermal, I will have my points on a line going through 0, 0, because this is a line going through 0, 0, where the slope is the specific heat capacity. This method can be used to find a specific variable, okay, that we want to measure through a best fit analysis. Why are we doing this? Because LoggerPro is using a method that is called square list regression, that it's much more complex and insightful than what we could do by hand, calculating A for each couple of point xy. I hope this video clarifies why we're doing this. Hi.